Hello everyone, welcome to Infigyan once again. In this very exciting video, we are going to simplify one expression which is based on complex number. Expression is square root I plus square root of minus I. Because of it is iota involvement, we will see the property of iota or imaginary number I. We will see the Euler's identity. We will use De-moivre's theorem. And overall, I am going to solve this question by three different approaches. I won't say method. I will use three different approach. Let's start with the first one. Let's consider the given expression as z. Now, let us consider this is 1a and square root of minus I is b. Now, what I am going to do, I am going to take the whole square both sides. So, it will become square root I plus square root of minus I whole square. Now it is a plus b whole square. This algebraic identity we know a square plus b square plus twice ab. So let's use. So z square will be equal to root I whole square plus square root of minus I whole square plus 2 times root I times minus root I. Now square root and square term will get cancelled out. So it will come out I plus minus I plus 2. Now property, that is square root a times square root b, we can write square root ab. So square root I, square root minus I will put square root once and then I will multiply I and minus I. Now you can see the first two term, that will be 0. It is equal to 0. So let me write 2 square root minus I times I, so I square. Now we know that because of I is equal to square root of minus 1, I square is equal to minus 1. You will take the square of that. So minus I square will be plus 1. So I am going to substitute here. So that will be 2 square root of 1. So square root of 1 is 1. So answer will be 2. Left hand side is z square or z square. Take square root both sides. It is z square is equal to 2. Once you take square root both sides, z will come out plus minus square root 2 by taking square. This approach is called squaring of complex number method. Let's consider the second method, second approach. Second approach is minus iota or minus I. It is equal to 1 over I. How? Let me show you. Minus I, if you will multiply by I in the numerator denominator, then it will become, see, minus I, if you multiply by I in the numerator denominator, then it will be minus iota square over I or I square over I. Now minus I square is 1. So it is 1 over I. Now I am going to substitute here z equal to root I plus 1 over root I. Now this is recalling actually x plus 1 over x form. So let me take square both sides. See, once we will take the square of x plus 1 over x form, then x into 1 over 1 over x, that will generate 2 actually. So let's take a square. So a square will be root I square same way plus 1 over root I square plus 2. This is what I was saying. 2 times root I into 1 over root I, that will be cancelled out. So it is I plus 1 over I plus 2. And 1 over I is, you have written there, minus I. See. So I minus I plus 2 equal to 2. This term will be cancelled out because of square root. This term will cancel out. Now z square is equal to 2. So z will be equal to plus minus root 2. Second approach, just by using the property of I. This is the property. Now third method, that is conventional method, or third approach, that is conventional approach, where we will use exactly Euler's identity and De-moivre's theorem. See how I is e raised to the power I pi over 2. And here we will write minus I as e raised to the power minus I pi over 2. Iota is I is e raised to the power I pi over 2. By Euler's identity, you can write cos pi over 2 plus I sin pi over 2. Cos pi over 2 is 0, sin pi over 2 is 1. So that is why it is 1. So by Euler's theorem or Euler's identity, we can write in terms of exponential. So now let's put the value. So equal to e raised to the power I pi over 2, that is I only. Square root is there. So I am taking half. Plus e raised to the power minus I pi over 2, half. A raised to the power b raised to the power c. Then we can multiply the exponent. Multiply it. E raised to the power I pi over 4 plus e raised to the power minus I pi over 4. Now e raised to the power I theta plus e raised to the power minus I theta. See, I can write here. Okay. E raised to the power I theta is cos theta plus I sin theta. E raised to the power minus I theta is cos theta minus I sin theta. By Euler's identity, if you will add simply, then sin theta term will get cancelled out. So e raised to the power I theta plus e raised to the power minus I theta, that will be equal to 2 cos theta. Okay. So e raised to the power I theta plus e raised to the power minus I theta, I will write directly, it is 2 cos theta. Theta means pi over 4. Now this is for principal solution only. Okay. So this is 2 cos pi over 4. So cos pi over 4 is 1 over root 2. One root is very clearly square root 2. But if you want to find out general solution, this is principal value. If you want to find out the general value, then we will use here plus 2n pi over 4. Generalize this plus 2n pi over 4. This is how you can proceed. So by this, once you will generalize it, it will come out plus minus general solution. So that z will come out plus minus 2 cos pi over 4, that means cos 45, 1 over root 2. That value will be plus minus root 2 times root 2 over root 2. So z will come out plus minus root. This is using De-moivre's theorem, Euler's identity, properties of iota or imaginary number I. So there are three approaches. We actually shown you in the matter of, see, the complex number question, how it can come in the form of non-conventional form, means without any complex number in terms of base and its exponent. So we will be ready for exponent and base problem. Thank you so much for watching. Please do subscribe my channel and give like impression also.